Hello, folks. Today's lesson is section 9.5, tangents. Let's get started. Okay, it's a short lesson, so I'm going to put the entire lesson on one video for you. Section 9.5, tangents. A tangent is a line in the same plane as a circle that intersects the circle in exactly one point. That point's called the point of tangency. AB is tangent to circle C. Take a look. So the point of tangency is that point A right there. So AB and ray AB are also called tangents. A common tangent is a line, a ray, or segment that is tangent in two circles in the same plane. In each figure below, the line L is a common tangent of circles F and G. Take a look. So you've got circle F over here and circle G. Okay, so you've got the L running through there. You got a point there on circle G and a circle F. Take a look at this one also. There's the point there right on circle F and circle G. Okay, let's go right to example 1. Draw the common tangents in the figures below. If no common tangent exists, state no common tangent. All right, here's the first one. So this will be a little tricky with the smart board today. So we're going to run a line just like this. It's going to touch one spot on each circle. That'll be one area. So we got a tangent, point of tangency there and a point of tangency there. Another one is down here, running across. It's got your point of tangency here and a point of tangency there. Letter B, take a look. Two circles, quite a few here, so let's do this one first. We'll do the bottom one. We got one kind of going down like this. Got the spot there, and the spot there. And likewise, we're going to take and go this way. So that'd be letter B. Letter C. Okay, we got ourselves one that runs right through here. Oops, a little bit crooked there. We've got another one that runs the top one. And we've got one here at the bottom. And that would be letter C. Take a look at D. Circle and a circle here. Target. This would be none. None. Okay, so next page. We're talking about the shortest distance from a tangent to the center of a circle is the radius drawn to the point of tangency. All of the theorems applying to tangent lines also apply to parts of the line that are tangent to the circle. The theorem below is one that we will use a lot in this chapter. Let's take a look at this next 9.1. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So line L is tangent to circle S if and only if L is perpendicular to ST. Okay, so line L, which is this line right here, is tangent to circle S if and only if line L is perpendicular to ST. Okay, so take a good solid look at that. Let's do a couple of these problems quickly. You will be asked to determine if a segment is tangent to a circle. So they'll ask you, is it tangent to the circle? Here we're going to use the Pythagorean theorem. So let's start with this example 2. Determine whether each segment is tangent to the given circle. So we have ourselves LM, the radius, 20, and 21. We're trying to take a look to see if MP, we're going to determine whether the segment is tangent to the circle. So if it is, it's a right angle right there. So we're going to take this 28th hypotenuse, 20 and 21 is are the legs. So we're going to check to see if a squared plus b squared is equal to c squared. So by the use of the Pythagorean theorem, we've got our two legs, 20 and 21. And we're putting it to test. We're putting to the test, so we've got a question mark here. And we're checking to see if it's going to be 28 squared. Okay. So this is 400. 20 times 20 is 400. Then if you add that to 441, we're doing a test to see if it's equal to 28 squared, which is 784. 784. Okay. So that is not equal to it. So if it is not, we just determined that this MP is not tangent to the given circle. Okay, so check these types of questions out on an upcoming test, quiz, or worksheet. Letter B, QR. Okay, so we're checking to see if this QR is 48, is tangent to the circle P. So if it is, we've got ourselves a right triangle there. So we're checking to see if 14 squared plus 48 squared is equal to 50 squared. And that is a Pythagorean triple. So this is a triple, 14, 28, 50. Did I say 40, 14, 48, 50? So this is a triple, and so we have ourselves a tangent. QR is tangent. Yes. Moving down to letter C. Here we have XY. We're checking to see if XY is tangent to circle Z. Okay, if it is, we're going to check to see if the Pythagorean theorem works here. So we've got ourselves 8 squared plus 4 squared, and we're putting it to the test. We're checking to see if it's going to be the square root of 80 squared. Okay. 8 squared is 64. 4 squared is 16. And the square root of 80 squared is 80. And so you can see that, yes, we have ourselves a tangent XY. Example 3. JL is a radius of circle J. Determine whether KL is tangent to circle J. Okay, so again, we're checking to see if KL is tangent to the circle J. So we have ourselves the legs 8, 15, and the hypotenuse of 9, or 17, I should say. This is 9 plus the 8, okay? So we have a point way out here. So we have the radius of 8 from this plus the 9. So I'll make a little arc there, and that's 17. So 8 is the one leg, the radius. 15 is the tangent we're checking, is the other leg, and 17 is the hypotenuse. And that is a triple, Pythagorean triple. Okay, so if you want to verify that, you could always do some calculated work on that. But yes, that is a Pythagorean triple. All right, moving on to the next page. Example 4, tangents. Determine whether GH, right here, is tangent to circle F. Justify your answer. All right, let's get started. So we got ourselves GH, which is 8. So we're checking to see if 8 squared plus the radius here of 6 squared is equal to, we have ourselves 12, this little section's 12, but then we have a 6, okay, of the radius. This is 18. Okay, so this is 18 all the way across. So we're checking to see if that is 18 squared. And so 64 is 8 squared, 36 is 6 squared, and we're checking to see, make sure I put a little question mark there. We're checking to see if that is equal to 18 squared, which 18 squared is 324. And that is not. 64 plus 3 is, or 36, is not equal to 324. So your answer there for example 4 would be no. No. So take a look at those types of examples in some upcoming work. Tangents, continuing on, we're on page 3. There's only 4 pages of notes today. So we can also use the last theorem to identify missing values. Okay, so we're going to take a look at this question here. Example 5, find x. Okay, that's the hypotenuse now. Assume that segments that appear to be tangent are tangent, round to the nearest hundredth. Okay, so we're just going to make the assumption that we have ourselves a tangent. JK is tangent to the circle H. So if that's the case, we're going to have the Pythagorean theorem of a squared plus a b squared is equal to c squared. Okay, so let's fill in here. We got the legs, the 15 squared plus the 20 squared. And that's going to equal c squared. Now c squared we're going to call x squared. So 15 squared is 225. And 20 squared is 400. And that's equal to x squared. 225 plus 400 is 625. Is equal to x squared. Undoing that square root, we're going to take the square root of 625. You get the value of x to be 25. And that is letter A. So we're assuming that this JK is tangent. So we're assuming that. And we're trying to find the value of x by the use of the Pythagorean theorem. All right, let's go on to letter B. Take a good solid look at this one before we get started. We've got a circle here. We're assuming this ZB here is tangent. So we're going to put a little right angle there. So we're going to check to see if 21 squared plus x squared is 29 squared. Now, 29 comes from this 21, it's a radius. So we have 21 plus the 8 And that will put you at 29. Okay, so we're checking to see if 21 squared plus the x squared is equal to 29 squared. So we're going to try to solve for x. 21 squared is 441. Okay. 29 squared is 841. So if I subtract 441 from the left side and 441 from the right side, I'll have x squared is equal to 400, and that's going to put your x to be 20. Square root of both sides. X is 20. So be on the lookout for those types of questions coming up. We've got one more, and then we've got one more page. Couple left. Okay. All right, here's letter C. We have an x, which is the radius. This is also x here, and then we've got 8, and we got 12. So we're trying to solve for x. So if that's the case, we're going to start with the Pythagorean theorem of x squared plus the 12 squared is equal to x plus 8 squared. Okay, so let's solve this. We have some FOIL to do over here. Okay, so x squared plus 144. Now, if I expand this out, I have x plus 8 times x plus 8. Some of you might say, well, I know that there's a certain relationship here. We could go right if you remember that, but we're just going to use FOIL. FOILs are our go-to way of multiplying the two binomials. So the first times first is x squared. Outer is 8 times x, 8x. Inner is 8x. And last is 8 times 8, 64. Okay, so x squared plus 8x plus 8x plus 64. So let's simplify this down a little bit. On this side, I have x squared plus 144. Okay, so you're going to notice here, I've got an x on this side and an x squared on this side. So x squared on this side and this side. So I'm just going to cross those off. They cancel each other out. But I've got this little 8x plus 8x, and that's going to put me at 16x. 16x. That's a like term. Then we're going to add 64. And then I'm going to still have my 144 on this side. So now I'm going to subtract 64 from this side and 64 from this side. And that puts me at 80. 80 is equal to 16x. And dividing by 16, you got x is 5. Dividing by 16 on this side and 16 on this side, you get x is 5. So keep a lookout for those types of problems coming up on a test or a quiz. Last page today of notes for tangents, section 9.5. more than one line can be tangent to a circle. If two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so this diagram here, you've got your two tangents with the point, same exterior point. So AB is tangent to the circle D, and CB is tangent. So if segment AB and CB are tangent to circle D, then we can conclude that this is congruent to this. Okay, so if this is, let's start with example 6. See if we can work through it. These are pretty quick. So assume that segments that appear to be tangent are tangent, round to the nearest hundredth. So our option here is to find x. So we're assuming this is tangent, and this is tangent to circle R. So if it is, we have 3x minus 6 is equal to x plus 10. X plus 10. Okay, so now we're going to solve for x. If I subtracted x on this side and I subtracted x on this side, I have 2x minus 6 is equal to 10. And then I'm going to add 6 to this side and add 6 to this side. And 2x is 16. 2x is 16. And undoing this multiplication with division by 2, you have x is 8. X is 8. So you're going to have some questions like this coming down the pipeline. Okay? This problem here, you have 4x plus 2. We'll kind of do a couple of these quickly. They're pretty straightforward. Again, we're assuming that these are tangents, so we can then say 4x plus 2 is equal to 2x plus 8. Subtracting 2x from both sides, I have 2x plus 2 is equal to 8. Add or subtract 2 from both sides. This side and this side, I have 2x is 6. And x is 3. So those aren't too tough. You might also have questions like the last section here. Example 7, it says you can use the theorem to find missing measures in circumscribed polygons. So let's get started on this one, finish up here. We've got ourselves a circle that is circumscribed. It's inside this triangle here. So what you can do is find the perimeter. They're asking you to find the perimeter of this all the way around. So you got a few problems here like that. So what you can do is just basically fill in the blanks. So if you know that this is 4, this is 4. And if this is 13, this is 13. And if this is PS, 2x equals 9. So 2x would equal 9. Okay, that would mean that x is equal to 4.5. Okay, so if you're looking for the perimeter of this triangle, you're going to start at one point and start adding them all up. You're going to start with this 4 here. You got 4 twice. 4 plus 4. Then you're going to add your 13s. Okay, so you're going around the horn here. 13. And then add your 13 again. And then you're going to add your 4.5, or actually 9. Okay, because this 9 is this spot. Okay. I did have a note here to find x. Okay, so this x is 4.5 and be part of the problem. So you've got 9 and 9. Okay, So perimeter, add it all together, 52. Perimeter of the triangle is 52. So keep a lookout on for those types of problems. Other than that, that's pretty much it for the lesson. Hopefully you found it helpful for you. I skipped a few on the couple of them, but they're pretty straightforward. Keep the length of the video down. And hopefully it's helpful for you on section 9.5 tangents, and hope to see you soon. Take care now.